So to continue with ID24, up next we have Mark Sadecki. He's here from the W3C to talk about recent advances in the accessibility of HTML5 Canvas element using a simple game that he designed to be accessible to keyboard, screen reader, and screen magnification users. Mark right now is a staff contact for the HTML Accessibility Task Force, which manages the progress of accessibility solutions in HTML5, including extension specs like Canvas 2D. So without further ado, we'll turn it over to you, Mark.
Great, thanks a lot. Oh, it says I'm echoing Shane, so why don't I turn my volume down, and if anybody has anything to say, I'll keep an eye on the chat window. Okay, good. All right, so thanks for having me here on Inclusive Design 24 on Global Accessibility Awareness Day. You can follow along with this presentation on your own computer if you'd like, if you want to follow links, and etc. The URL is on the title slide here. It's j.mp /a11y-canvas. Should take you to an HTML version of this presentation. All right, so when Carl Groves told me last week that he absolutely needed to have a title for my presentation, the only thing that came to mind was the terrible cliche past, present, future. When I went looking for images for the title page, I found this terribly cliche image, and I said to myself, well, if you're going to be cheesy, you might as well own it. Then the universe spoke, and I found this joke, and that's when I knew I could pull this title off. So the joke is the past, the present, and the future walked into a bar. It was tense. Okay, so today's agenda, I'm going to do a brief introduction, talk about some of the accessibility challenges of HTML5 Canvas. We'll talk about past, present, and future solutions. And then we'll talk about this little game I designed using some of these new features. And hopefully the demos all work. Okay, so my name's Mark Sadecki. You can follow me on Twitter at CPTVitamin. It's a name I got way back in college. We won't get into the details. I work at the World Wide Web Consortium on the at the Web Accessibility Initiative here at the in Cambridge, Massachusetts, on the campus of MIT. I'm a staff contact for the HTML Accessibility Task Force, the Canvas subgroup, and the media subgroup, and bug triage. Most of the stuff that we're going to be showing you today is the direct result of the work we've been doing in the Canvas subgroup over the last 4 months. Oh, I see John Croston's left a comment. Yeah, I gave this presentation last weekend, and people were trickling into the room up to 5 or 10 minutes late, and I got to tell that it can't be a past, present, future joke 3 or 4 times. Okay, before we jump directly into the accessibility challenges of Canvas, let's lay the groundwork for what Canvas actually is. So Canvas is a 2D drawing API that allows you to draw pixels to, well, Canvas. It doesn't sound all that exciting, but when you take into account the power and flexibility of JavaScript, there really is no limit to the creative, dynamic, interactive widgets, games, and animations that you can do. But whenever I hear the word image, my accessibility radar starts buzzing, and the words interactive and bitmap, and I really start to get concerned. There are inherent accessibility challenges with bitmap images, and those challenges get magnified when you make them interactive and dynamic. So when Canvas first appeared on the scene, 3 fairly serious accessibility barriers emerged. First one was addressed a few years ago, but the other 2 are still lingering. Let's look now at those and talk about some solutions that are available either now or in the near future. Okay, challenge number one. There's actually no content to interact with. So originally, when Canvas first came out, you had your Canvas element, and whatever happened in the canvas stayed in the canvas. There was no way for a screen reader, for instance, to access any content within that canvas. So you could use JavaScript to draw all sorts of uh, cool shapes and graphs and widgets and interactive graphs and widgets as well. And there was no way for a screen reader user to access any of that. I have a graphic on the screen of Shia LaBeouf on SNL mouthing the word magic and waving his fingers through the air. He also has a unicorn on his t-shirt, which I think is important to point out. So we came up with the idea of fallback content. Fallback content's not a new concept, but we changed the way it worked for Canvas. So if anyone's familiar with fallback content, it was usually reserved as a means of providing information to a user who didn't have technology to access the element that was being used on your page. So basically, if you didn't support a particular feature, you would get the fallback content. But for Canvas, we kind of changed that and we said everybody, the fallback content is going to be actually right in the DOM, and other user agents like screen readers can access it. So I have an example of a Canvas element on the screen right now, and with some basic HTML in there. I added some IDs to the H1 element and the button element. We'll talk about why I would want to do that in a little bit. So fallback is just fine if you want to give screen reader users access to the raw data for a graph, for instance, or a text equivalent for an image or bitmap text. But it's going to come up short if your graphic is dynamic or interactive. So fallback content's been around. This solution's been around since about 2010. It's well supported by browsers and AT. It was actually an HTML5 solution, not a Canvas one. All they did was say we can allow content between the Canvas elements, the Canvas tags now. So the problem with this is that there's no programmatic link between the Canvas and the fallback content. So if you want to provide an alternative description for a graph, for instance, you can put the raw data that was used to create that graph in the fallback content, and a screen reader user can browse that table like you would normally, and have access to the raw data for the graph that you were displaying using Canvas. So we have this great concept of fallback content, but Canvas was designed to be dynamic and interactive. How can we map or associate pixels drawn to the canvas with those great fallback elements that we can now put between the canvas tags? How do we pass mouse events from the canvas to the fallback elements? And how do we inform the accessibility APIs of the location of those fallback elements? The fallback elements, say you draw a circle in your canvas and you want that to be a button, for instance. So you want to map that to a button in the fallback content. You wouldn't want the focus that's drawn around that circle to be in the shape of, the standard shape of the button that's in the fallback content. So we need a way to associate that region of the canvas with the fallback element. So the Canvas subteam redefined, I say redefined, the concept of hit regions. So hit regions are regions on the canvas that can be hit or interacted with. It's an old term that comes from when graphical user interfaces first came on the scene, and they were looking for a way to detect when and where a mouse action occurred on the interface. hit regions first appeared in the what working group spec for HTML5 a long time ago, probably around 2008 or so, I believe. And it was subsequently in the HTML spec as well. But it was removed from the W3C spec because not a single browser vendor was implementing the feature. This usually indicates that the feature is either overly complex or poorly designed or both. So the Canvas HTML Accessibility Task Force saw this as a major setback because we really wanted a way to associate regions on the canvas with fallback content. So what we did is we got some implementers together, formed the Canvas subgroup, and we met regularly to see what we can do to improve the existing hit region spec so that implementers would actually support it in their browsers. So we came up with a simplified version of hit regions that remains forward compatible with the existing hit regions that was in the what working group spec. And we got buy-in from browser vendors. We thought that this was doable. And what we ended up with was we defined the hit region and the hit region list. We defined how mouse events are going to be handled. And we added 3 new methods. We have the add hit region method, remove hit region, and clear hit regions. Okay, challenge number 3. Most of the people we know, most of the people in this chat room, probably understand the importance of focus indicators. It's impossible to use a graphical user interface with just a keyboard without a mechanism for indicating focus. There's no way for users to know what element will receive keyboard interaction in the canvas. The canvas spec originally had draw system focus ring and draw custom focus ring, but there were no implementations again. Browser vendors said the methods were poorly named and poorly designed. So the Canvas subgroup got together and took a look at the problem, and we came up with a new method called draw focus if needed. So draw focus if needed. We got buy-in from the vendors. They liked the name better. Some people were put off by the use of the word ring because you weren't actually drawing a ring on the canvas. It could be any shape because the focus indicator will take the shape of the path that's on the screen. So we have a new name. It draws a focus indicator around the current path of the fallback element associated with that path currently as focus. It will scroll the current path into view if the path is off screen, and it will inform the accessibility API of the location of the currently focused element. So this solution combines the best features from both Draw System Focus Ring and Draw Custom Focus Ring. And it's easy to include in each and every drawing function. That was important to us because while an author could hack their own focus solution together, they were less likely to do so unless it was a native method that they could easily use, so that instead of rolling their own. So, can I use these new features, hit regions and draw focus if needed? Well, it's so present it could be future. Currently, these 2 features are only supported by Firefox Nightly, and it's unfortunately only a specific build. We thought we had it in Firefox Nightly for good, but some reviewers took a look at the code and wanted it to be refactored a little bit. So we're working on refactoring that and getting it back into Firefox Nightly. If you want to download, I have links in my presentation. I have links to the specific build that should work, you do need to enable a couple of experimental flags once you have the browser installed. You have to have canvas.focusrings.enabled set to true and canvas.hitregions.enabled set to true. If you're not familiar with enabling and disabling flags in your Firefox browser, all you have to do is type in about:config in your address bar, and you'll get a whole list of settings that you can customize for your browser. If you can search, there's a search field you can use to just type in canvas, and that'll limit it to just 5 or 6 choices. All right, so building an accessible game using HTML5 canvas. So the challenges: I'm not a game designer. The game needs to use all these new features that were implemented just a few weeks ago. The game needs to showcase the accessibility benefits of these new features. And I only had 1 week to design, build, and test this game. So please do not be expecting any Call of Duty. All right, so before I got started, I set up some guiding principles for myself. I wanted a game that could be usable by keyboard users, screen reader users, and screen magnification users. But more importantly, I wanted it to be equally challenging for all. I really wanted to come up with a game idea that was universally designed. So there were no modifications that had to take place depending on your level of ability. And I think I did a pretty good job. So the idea that came to mind was the old classic game Whack-A-Mole. I thought it was easy enough to build a prototype of. I had a pretty simple concept, and it would allow me to showcase some new features, these new features, and satisfy all of my guiding principles. So where I deviate from Whack-A-Mole, so I had to make some changes in order to reach my goals. So I can introduce those now. So in the traditional Whack-A-Mole game, you have, well, it was in the old days, it was a physical board where a character, a mole, would pop up through any given number of holes, and you would physically hit it with a hammer and score points. In order for this game to be universally designed, what I wanted to do is I ended up adding 2 characters. So one is bad and should be whacked. You'll get 10 points if you can successfully do that. And the other one is good and should not be whacked. If you do hit a good character, you'll lose 10 points. There's a fixed number of opportunities to score, 10 of them. So if you successfully hit all 10 characters, you should get 100 points. We're not whacking moles. My daughter was closely involved in the design of this game, and she suggested characters from her favorite video game, Minecraft. I agreed since they would be relatively easy to draw using Canvas. Minecraft characters are basically just blocks of blocks, and drawing squares in Canvas is actually really easy. We chose creepers for the bad characters, and Steve, which is just your generic player for the game, as the good character. So the game will be called Whack-A-Creeper, not a Steve. So gameplay. The player moves focus to and then activates the start button. Then characters will randomly start to appear on the board with a pause between each. The player is either going to click or hit enter on the creepers to score 10 points. They'll do nothing if a Steve appears. The game ends when 10 creepers have appeared on the board. The game mechanics. Okay, so the game board consists of a canvas element with a number of paragraph elements as fallback content. The first paragraph element is what I call the status button. You'll use it to start the game, but it also functions as an area that the game will return focus to periodically to let you know the state of the game. let the user know the state of the game. That paragraph tag is followed by 9 additional paragraph tags with unique IDs. And then there is one more paragraph tag that I created as an out of bounds. So basically the way the game works is the user will, if they're a keyboard user, they'll use the keyboard to tab through the game. Every time the board gets reset, the focus will be returned to the status button where they'll get the current state of the game. The next tab should take them to the character, and I'll show you how that works. If they hit tab twice or too many times, there'll be an indication that they're out of bounds, so they know they can either shift tab or wait for the board to reset. Outside of the canvas, there's an area to display the score. I have an ARIA Live of Polite on that area, and the status button has a ARIA Live of Aggressive, because it's probably the most important indicator that there's an action waiting to be done in the game. So drawing the character. The game starts. A random character is drawn in one of 9 grids. A transparent hit region is drawn over the character and associated with corresponding fallback element. That element is made focusable, so I just used JavaScript to add a tab index of 0. So at that point, the user's next tab will move focus to the character that just appeared on the screen, on the canvas. That element's text content is updated with the name of that character. So a screen reader user will hear the name of the character. It's either going to be a Creeper or a Steve. After that, focus is moved to a neutral location, which is the status button. Drawing the character. So drawing squares in canvas is easy. I have a little piece of code there that draws a 5x5 pixel square. I created an array of colors for one of the characters, and I just looped through the array to create one of the Minecraft characters. So here you have on the screen is Steve from Minecraft, and we actually drew that in the presentation using Canvas. So again, I just looped through 8 rows of 8 color boxes and drew that character. Oh, sorry. Thierry asks, is it aggressive or assertive? It's assertive. In the source code, it's assertive, clearly. I must have did a find and replace or something that changed to aggressive. Thanks for pointing that out. I'll have to update my slides. It's not in the source code, it's only in the slides. Okay, so at this point, the player is either going to take action or not. So the player is going to click on a character or use a tab key to move focus to that character and press the enter key. If the player is using a screen reader, the name of the character will be read aloud when focus is moved to it. At that point, the score is calculated and updated. If the player does not take action, the game times out and the board is refreshed. Okay, accessibility. So how do hit regions play into this? So each time a character is drawn on the grid, a transparent square is drawn over the character. A hit region associates that square with the corresponding paragraph element. As far as the accessibility API knows, that paragraph element's bounding box is that of the hit region. Screen magnifiers can use that info to drive magnification to the hit region. So here's a little snippet of the hit region script. So I can draw a button by drawing a rectangle at the X and Y coordinate of 0. with a length of 100 and a height of 30. We'll fill it with the color green, and then I will add a hit region. I give the region an ID that is within the namespace of the canvas, and then I also give it the ID of its corresponding fallback element, which is referred to as the control. Okay, draw focus if needed. So whenever a focus change event occurs, I call the draw focus if needed on an element. Focus ring is drawn around the hit region if that fallback element currently has focus. Focus change events are whenever the mouse is clicked on a hit region, the tab key is pressed, or the game board is cleared or reset. Okay, draw focus script. So I called this function whenever I drew a path to the canvas that was associated with a fallback element, and I wanted to move focus to it. Okay, so again, I'm going to get at this point I'm going to do a demo of the game. Once again, it only works in this particular version of Firefox Nightly with the canvas focus ring and hit regions enabled, set to true. It's currently short on features. I literally threw this together in just a few days. I definitely have plans for improving it, and so does my daughter. I only have limited testing with speech and magnification. Again, it was just a time issue. So normally, if I was in the same room with you guys, I would do a live demo. But I was a little concerned about that today, since we were doing this over an online webinar. So I hedged my bets, and I did some screen recording and put those up on YouTube. So what we can do is we can watch those. So I recorded 3 screencasts, one playing with the keyboard, another with a screen reader, and one more with a screen magnifier. I apologize for the poor quality, any stuttering I do. I just put these videos together a few hours ago and didn't have the luxury of multiple takes or any editing. I did manage to create some captions, but haven't done any video description yet. So I hope to get to that this weekend. Okay, so I can try playing this video. I don't know if you guys will hear it. If you don't hear it, what we can do is there's a link, a short link, so you can actually watch it directly on YouTube on your own computer. I included that just below the video. So I'll play that now. Should probably turn up my volume a little bit. Video, I'm going to demonstrate how the game is played using a keyboard. You'll also be able to view the DOM inspector and watch as changes occur in the DOM during gameplay. So I move focus to the start button. And hit enter to activate it. And characters start to appear in one of 9 locations on the game board. Each grid corresponds to one of 9 paragraph elements that are children of the canvas or fallback elements. When a character appears on the board, the tab index of the corresponding paragraph element will change from -1 to 0, making it focusable. There are only 3 focusable areas on the board at any given time: the status button, the currently active grid location, and the out of bounds indicator. After each refresh, the focus will move back to the status button. What you can't see, because the nodes are collapsed, is that the name of the character is being added to the text value of the corresponding paragraph element, so that when a screen reader user moves focus, they hear the name of the character. I'll continue to play until 10 of the creeper characters appear on the board. every time I hit tab, you'll notice a focus ring appear around the character that is on the board. There's an out-of-bounds region beyond the game board, so that if a player hits the tab key twice, they'll get an indication that they're out of bounds, and they can either wait for the board to reset, which will reset focus to the status button, or they can shift tab to reverse to move their tab focus in the reverse direction. All right, 90 out of 100, not bad. So that was the experience for a keyboard user. The game is pretty slow at this point. It's set by a simple variable in the JavaScript. I kept it slow so that, well, one, I could have time to actually play the game and describe the game at the same time, and so that people could see the changes that were happening in the DOM, hopefully. So the next demo is going to be the game experience using a screen reader. So we'll hit play and see what happens. Okay, in this video I'll be excuse me. Okay, in this video I'll be demonstrating the game experience using the NVDA screen reader. You'll notice that the start button is announced and that the player can activate it with the keyboard, at which point characters will start appearing on the board. The player will use the tab key to move focus to the current character to hear its name, at which point they can choose to take action or not. The game board will reset once the specified time elapses, and then focus will be returned to the status button. The status button has an ARIA live value of aggressive, so the user will be informed every time a new character appears on the board when they hear the word go. I'll go ahead and start playing now. Focus accessibility past, present and future visited. Full instructions for gameplay. Firefox nightly visited link. Clickable start. Out of bounds. Start. Alert. Clickable creeper. Alert go. Creeper. 20 go go. Creeper. 30 go. Steve. Alert. Creeper. 40 go go. Creeper. Alert go. Steve. Alert go. Steve. Alert go. Steve. 50 go. Creeper. 60 go. Steve. 60 go. Creeper. 70 go go. Creeper. 80 go go. Creeper. 90 go. Clickable go. Steve. 90 go. Creeper. Wait. 100. Wait. Test come closest. 1. Okay. All right. So that was the basic experience for a screen reader user. It wasn't ideal. There's definitely some room for improvement there. In the beginning, this was all theoretical, and I actually didn't get a chance to do any testing until the morning of the first time I gave this presentation, which was this weekend. I made some quick minor adjustments based on real-world experience with a screen reader, and I definitely think there's room for improvement there. But that's the basic experience. I thought it was pretty cool to create an experience that was similar for an able user, a keyboard user, and a screen reader user using this this new technology. Okay, so the last demo I have is using screen magnification. There we go. So this video is actually a video of my computer taken from my phone because I realized today that screen recording software records the video stream before the screen magnifier magnifies it. So I kept making these videos and the screen wasn't magnified. Um, and I tried different screen magnifiers, screen recorders, and they all did the same thing. So I finally just set up my phone to record the screen. So the experience will be a little bit different.
Okay, in this video, I'll be demonstrating the game experience using the Magic Screen Magnification software. This is where the accessibility features of hit region come into play. You'll remember from my presentation that adding a hit region updates the location of the corresponding fallback element in the Accessibility API to the location of the corresponding region on the canvas. This helps screen magnifiers pan the user's screen to follow focus changes. I had to record this video using an external device, since screen capture software records the image before it gets magnified by screen magnification software. Okay, let's play the game. So I'm moving focus to the start button. And I'll start the game. You can see that when I move focus to a character, the character's region moves into the center of the screen. And focus is also returned to the status bar, the status button, every time the board is reset. You'll also notice the focus ring appearing around the character each time I move focus to it.
All right, so that's the end of the screen magnification demo. Again, this is really cool because this was all theoretical. It was all based on we tried to design these new features so that they worked seamlessly with existing support for accessibility APIs, and so basically all we're doing is we're changing the physical bound of the fallback content in the accessibility API to that of the region, the bound of the region in the canvas. And that allows the screen magnification software to know exactly where to pan the screen when focus is moved, and also where to draw, and also tells the browser where to draw the focus indicator. So that's my last slide. You can follow me on Twitter. You can look at this presentation online. You can play the game if you install the browser and customize the flags. You can take a look at the project on GitHub, file some issues and pull requests. I'd be glad. I'm a amateur JavaScript developer, first-time game developer, so I'd definitely be interested in your feedback. Like I said, there's lots of room for improvement in the game, and I'd love to hear your ideas. So John asks, what other features do I plan on adding to this game? I'm thinking about making the size of the board dynamic rather than having it confined to just 9 grids. Also adding a speed slider to allow the user to change the speed. Also, we thought about making the transitions times random rather than fixed, so you wouldn't know exactly how long the character would be on the screen. What other feature did we talk about? Maybe an intermediate and advanced mode where there would be 2 or 3 characters appearing on the screen at the same time, and the user would have to tab an indeterminate amount of time to find the creeper versus the Steve. So those are definitely some ideas for improving the game. We finished a little early. If anybody's interested, I could walk you through the source code. Um, if anybody would be interested in that. All right, let's see if I. All right, can everybody see that? So basically, I have some generic code to set up the canvas element and get the context. I defined the width and the height. That was my first attempt at making the board dynamic in size. You'll see here we have a creeper count set to 0. The score is initialized to 0. I have the color grids for the two characters, the creeper and the Steve. I have a function here called update text and draw button. Both of those are generic functions for drawing and updating the button that you see at the top of the canvas. The update grid function is the main game engine basically. So it updates the text status to wait, indicating that the board is in transition. So if a user were to move focus to the status button at that time, they would hear wait. I then draw a button and change the button text to play. I have a few functions here that grab random coordinates. So which handles the random coordinate the character is going to appear in, and then have a random function that determines if it's a creeper or not. It's basically 50-50 chance tossing a coin. If it's a creeper, I increment the creeper count. If it's a Steve, nothing happens. I have a function here that draws the character that was chosen at the given XY coordinate that was also randomly chosen. I then draw a hit region over that character. Then I update the status text to go because now the character has appeared. I update the status to go. I then so that happens repeatedly until you've had 10 creepers. So I have two timeout functions. One determines how long the character stays on the board, and the other it determines the pause before the game start and between each new character. Okay, so I have a function here that draws the creeper or the Steve. Again, I think we showed a little bit of this in the presentation. It's just a couple of nested for loops that pulls in a color for the grid based on that the array. Here's how we draw a hit region. It's basically the same thing. We just draw a square I have a little bit of an offset so that the hit region is slightly larger than the character to emphasize that focus indicator. I then make the region focusable with this function. I also add a text to the hit region, or to the fallback element here with the name of the character. And then I move the focus back to the status.focus, moves the focus back to the status button. Clear grid is something that happens every single time the board gets updated. It basically resets everything. It draws the canvas white. It makes all the grids not focusable. It updates the score. It updates the status to wait. And then it draws the button again and moves focus back to the status button. Here's where we have our event listeners. I handle key presses. Basically, the important key to differentiate is the tab key. Everything else is will act as a hit. I also have an event listener for a mouse click. Now, the difference between a key press and a mouse click is that the key press is the event is sent directly to the fallback element, where a mouse click is sent to the canvas. And what we have to do is we have to access the event.region, which is a feature of hit region. So there's a little reverse engineering I have to do in the tab process function to get at the hit region. So here we process a tab. Here we process a click. So the processing of the tab is basically just the reverse engineering, which I then use to call the click. At this point, this is when we do our scoring. If there was a value of creeper in the text node, then we give the player 10 points. If it was a Steve, they get minus 10 points. If they click anywhere else on the board, they also get minus 10 points. If the status happened to indicate the word start, then we start the game. That's basically what starts the game. And everything else after that is just utility functions for picking random coordinates and drawing squares and buttons and updating text. So that's it. Any questions? My pleasure. Thanks for having me.
All right. Well, if there are no questions for you, Mark, I'll let you
Great.
off the
Thanks so
hook.
much, guys.